In this video, we'll be exploring writing rate laws using elementary reactions and how they relate to writing the rate laws for a reaction. Let's get started. Remember that oftentimes, the most simplified equation for a reaction does not show the full picture of what's occurring. Elementary reactions remedy this by splitting up our reaction into each individual step which takes place and showing all species involved in these steps. Remember also that oftentimes, these elementary reactions include intermediary species. These are compounds which are created as a product in one elementary reaction and then consumed as a reactant in the following reaction. Like we do with variables in algebra, we can just cancel these species out from each side of the reaction, which is why we don't actually include them in our most simplified equation. When it comes to writing rate laws, we can use elementary reactions to aid us. I'm going to start off by explaining the process and then go through some examples with you. To start off, our first step is going to be locating the rate determining step. Below, I've written out an elementary reaction, and it has two different steps. As you can see denoted on the right side, these steps are going to progress at different speeds. Some are going to be fast, and some are going to be slow. Our overall reaction can only proceed as fast as the slowest step. That's why we name the slow step the rate determining step. When writing out our rate law, we are only going to include the reactants involved in this rate determining step. The second thing we have to do is write out our basic rate law equation. Remember that it reads as follows. What we also have to do is fill in the reactants in our rate law only from the rate determining step. So again, if this is our elementary reaction, these two steps, and we have the slow rate determining step over here, then the reactants in this step is going to be H2 gas and ICl. So we're going to put those reactants in our rate law. Something I do want to point out, if we had an intermediate reactant in this slow rate, we would not include it in the rate law. We never include intermediaries, and again, that's because we cancel them out. So for instance, in our first step, we are forming HI, and in our second step, we are consuming HI. We can cancel this out. This should not appear in the overall reaction, and if it had been in the slow step, we would not put it in the rate law. And then to finish off, for our third step, we just need to include the exponents signifying the order of our different reaction. And then to finish off, in our third step, we just need to include the exponents signifying our reaction orders. To do this, we just reference the coefficients placed before our species in our rate determining step. They will be exactly equal to the reaction order for that reactant. So a coefficient of 2 would signify a reaction order of 2, a coefficient of 1 would signify a reaction order of 1, and so on. So let's now write that for our rate law. We see that our hydrogen gas has a coefficient of 1, so the reaction order for our hydrogen gas is going to be 1. And our ICl also has a coefficient of 1, so the reaction order is also going to be 1. And so those three steps show how we would write the rate law for our reaction from our elementary steps. And I really want to stress that this third step, this is the only time in which we can use coefficients to find the order of our reactants. You can only do this when writing a rate law using your elementary reactions. For all other problems, you have to compare the change in concentration for species against their change in rates. In case you've forgotten how to do that or are unsure of what I'm even talking about, I have a video over it titled Introduction to Rate Laws. And so again, these three steps are the only thing you're going to have to do to find the rate law for a reaction using your elementary reactions. I'll now walk you through some examples to ensure you fully understand the process. Given the following elementary steps, find the rate law for the overall reaction. So for my first step, I'm just going to identify the rate determining step. That's my slow step. And then I'm also going to cancel out my intermediaries. Hydrogen here is serving as a catalyst, which I'll have a full video over in the future. So we're going to include it in the rate law. We're not going to cancel that out. For my second step, I'm going to write out my skeleton rate law equation, and then I'm just going to fill in all the reactants I'm using, determined by my rate determining step. All right, I've got that. And then lastly, for the third step, let's look at the coefficient in front of each one of our reactants, because that's going to equal our reaction order. We have a 1 here and a 1 here. And so then I can include these reaction orders in my final rate law. And so this right here is the overall rate law for my reaction given my elementary steps. Not too crazy of a process. And with that being said, that's all you have to know for writing rate laws using elementary reactions in AP Chemistry. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, take a break and come back after. Thank you for watching.